So the question over 9.2.7 T, so the T's here really kind of using the technology, and looking at the work, I think maybe two things went wrong here. This 0.17, looking at the problem you sent, should be 7.1, and then I'm not sure where this 1.96 came from. You're going to use the technology to find the corresponding T value that represents 90, or in this case a 90% confidence level for a specific degrees of freedom depending on a formula that's given in the book. So you can definitely do this by hand. Here are some of the formulas for the DF, where A and B are given here, and you can plug this in to find the DF. Calculate T is relatively simple. You're given everything you need, and then your error value is going to be similar to T, except you're going to multiply it by this T that represents 90% confidence interval for this given problem. So I want to just go over this example in my math lab on how to use the technology, and you can verify that you're going to get the same answer using the formula. So let's pull up this problem, and we're asked, looking at proctored exam and non-proctored exams, we want a 0.01% significance level, so be careful, that might change 0.05, which would correspond to a 90% confidence interval. 0.01 corresponds to a 98% confidence interval. So that's going to change your T critical value that you calculate. So using the technology, you just have to make sure that you plug it in correctly. We're going to look at the claim that the non-proctored tests are higher mean score than the proctored test. So our null hypothesis is that the two means are equal, and our alternative hypothesis is that the mean of the first group is going to be less than the mean of the second group. So looking at the options here, we're going to pick C. So the null hypothesis is that they're equal, and the alternative hypothesis is that the mean of the first group is less than the mean of the second group. So we're going to check that. We're going to look at the T statistic. You can definitely plug in the information into your calculator. If I go into StatCrunch and I open that up, I can also plug that information into StatCrunch, and it should give me the T statistic. So I'm going to click on Statistics, and I'm going to go to T statistics. I'm going to look at two samples with summary. So I'm going to plug in this information. We have 78.01 as the mean as the first group, 10.26 is the standard deviation, and we have a sample size of 33. The next information, we're given 19.22, sample size of 32. And we're going to look at the test hypothesis that mean 1 is less than mean 2. So we're looking for negative numbers here. And I can compute that, and that's going to give me the T statistic here. It's also going to give me the P value and the degrees of freedom using this two sample. So all these formulas have been plugged into this calculator. It also gives me the standard error and the sample difference when I go to find the confidence interval. I'm going to have to look up the corresponding critical value for T, and then I have everything I need. So the T statistic was given as minus 1.02384. I'm going to round 2 decimal places, so I get 1.02 minus 1.02. I'm going to check that. The p-value is corresponding. It's already given in that calculator. You can see over here I get 0.1556, rounding 3 decimal places, so I get 0.1556. So rounding 3 decimal places, I get 1.56. So the next step is going to make our conclusion. Now here we have to be careful. Our significant value is 0.01. our p-value is greater than our significant value, so we're going to fail to reject it, meaning there's not significant evidence to support the claim. So our p-value here is greater than our significant value. So we fail to reject the null hypothesis. So we can check our answer. Now the next part is going to be a confidence interval. And here we're going to look at the difference in the mean plus or minus, here, the difference in the mean plus or minus the standard error times our critical value for this test. So looking at the DF here, so with going to the calculator and going to the T calculator, looking for between, the DF is given. I'm looking for the critical value for T that corresponds to a 0.98% confidence interval. So that gives me 2.4 for this degrees of freedom, 2.4083. So write that down, 2.4083. So then I'm going to go back here to see the sample difference is minus 3.93 plus or minus the 2.4083 times the standard error, 3.83848. And I'm just going to write that. So just writing that out again, we get the difference in the two means plus or minus this t value that I found using the table that corresponds to the alpha over 2. So alpha here was 0.01, so that tells me 0.01 on the left and the right would mean a 98% in between. Given the degrees of freedom for the specific example, it gives me the corresponding critical t value, and that's going to be different for every problem, times the error. And again, you can find the error by looking at the calculator and plugging it in, or you can pull up StatCrunch and the error will be given, the standard error here. Sample difference is also given, so plugging that in, the sample difference plus or minus the critical t value times the standard error gives me these two numbers, and these two numbers would then be the bounds on that. Does this confidence interval support the conclusion of the test? Yes, because, well, I guess it would not support it because the confidence interval contains a 0. Or in this case, it would support it because we fail to reject it because it contains the 0. So that was a minute on the wording there. If you get the example where they're both positive or both negative, it would support but your conclusion would be to reject the null hypothesis if this p-value is less than the significant value. So here, since we failed to reject it, it does support our conclusion for the test because the confidence interval contains a 0. And here we are assuming that the difference doesn't include 0. So hopefully this explained what's going on here and showed you maybe a little bit more on the StatCrunch and where these numbers come from outside of just computation. If you have any other questions, please let me know.